Hello guys and welcome you all in the problem solving class of the course Applied Electromagnetics for Engineers. I am Vivek Kumar Shrivastava, a PMRF research scholar of Antenna and Microwave Research Laboratory, Indian Institute of Technology Ropar, and TO of this course. So in the today's class we will see some of the numerical based on the topics reflection and transmission of uniform plane wave incident on a dielectric media. Then we will see problems based on the topics Snell's law of reflection, refraction and Brewster's angle, and after that we will see power calculation that is carried by a uniform plane wave. So let us start. So here is the first problem. So the problem states that in free space, that is jet less than equals to 0, a plane wave with magnetic field is given to you, that is 10 cos of 10 raised to the power 8t minus beta jet, and the H field is oriented along AX direction, okay, in milliampere per meter. This is given to you, is incident normally on a lossless medium that is defined by its permittivity. Epsilon is equal to 2 epsilon naught and mu is equal to 8 mu naught, okay, and it is uh, occur in the region z greater than equals to 0. So by using this information we have to solve problem 1 and 2, which is the upcoming problem. Now in this problem we have to find the reflected wave, okay. So here in this problem, as you can see, so here this is the incident wave given to us, okay, incident magnetic field is given to us. So by using this incident magnetic field we have to find out that what will be the value of reflected magnetic field. Okay, so first of all, like here we can see that magnitude or the amplitude of magnetic field is given to us, that is 10 milliampere per meter. Frequency is also given to us, that is angular frequency, which is equals to 10 raised to the power 8 radian per second. And then beta, the value of phase constant, is not given to us, so we have to find out the value of beta here. Okay, so first of all, in the free space, the value of beta, that is phase constant, is defined as omega by c. Okay, so value of omega is given to us, that is 10 raised to the power 8, and c, that is the velocity in the air media, is equals to 3 into 10 raised to the power 8. Okay, so by using this we can calculate the value of beta 1, which is equals to 1 by 3. Okay, whereas the intrinsic impedance in free space is calculated by using this expression, that is root over mu by epsilon. So for uh, free space, as we all know, that mu will be equal to mu naught and epsilon will be equal to epsilon naught. Okay, so once you know the value of mu naught and epsilon naught, which is already given to you, okay, so you can calculate the value of eta 1, which is equal to 120 pi. Okay, so this quantity you can calculate. Okay, so this is, you have calculated for air media. Okay, whereas like for 1 minute, yeah, so actually my pen is not working, so sorry for that. So let us consider a free space. Okay, if suppose this is the region, okay, above this region, uh, a lossless dielectric media is there. Okay, having epsilon is equal to 2 epsilon naught and mu is equal to 8 mu naught. Okay, and below this region free space is there. Okay, which is defined by the properties of media, that is epsilon naught and mu naught. Okay, so in the air media you have calculated the value of beta 1 by using omega by c, and eta, which is the intrinsic impedance, and you can calculate it by using root over mu by epsilon. So once you put the value of mu naught and epsilon naught in the expression, that is for the air media, you can calculate the value of eta 1 as 120 pi. So now you have to also calculate the value of phase constant and eta 2 in the uh, dielectric media. Okay. So beta 2 is uh, defined as omega root over mu epsilon. So here you have to put the value of mu naught and epsilon naught which is given to you in the problem. Okay, so once you put the value of mu and epsilon in this expression, you will get beta 2 is equals to 4 by 3, whereas the intrinsic impedance of media 2 is defined as root over mu by epsilon. So here you have to put the value of mu naught, mu is equals to 8 mu naught and epsilon is equals to 2 epsilon naught. Okay, so once you calculate the value of eta 2, it will become equals to 240 pi. Okay, so you can also write this as 2 eta naught. Okay, where eta naught is the intrinsic impedance of the air media, which is equals to 120 pi. Okay, so once you calculate the intrinsic impedance of both the media, that is the air and the dielectric media, let us say, so you can calculate the value of reflection coefficient gamma, that is equals to eta 2, that is the intrinsic impedance of the media 2, minus, or say dielectric, minus intrinsic impedance of the air media divided by intrinsic impedance of the dielectric media plus intrinsic impedance of the air. Okay, so by using this expression, we can calculate the value of reflection coefficient, which is equals to 1 by 3. Okay, so once you know the value of reflection coefficient and incident value of magnetic field is already given to us. Okay, so what we will do, we can easily calculate the value of reflected magnetic field by using this expression. So amplitude of reflected wave is defined as minus gamma times uh, amplitude of incident wave. Okay, so here the minus gamma is occur it just because of the direction of the reflected wave is opposite to the incident wave. Okay, so in the region where the dielectric and air will meet, okay, so their reflection will occur in the opposite direction of the incident wave, so that's why minus sign is come here. Okay, so you can calculate the value of amplitude of reflection reflected magnetic field, which will be equals to minus 1 by 3 into amplitude of incident magnetic field. Okay, so this is equals to 10. Okay, so you can put the value of hi naught here. So the amplitude of reflected wave will be equals to minus 10 by 3. So the reflected wave is defined as hr is equals to minus 10 by 3 cos of omega t plus beta z. Okay, so here you also have to see that if let us suppose wave is incident in the positive z direction, so reflected wave will occur in the negative z direction. Okay, so that's why here positive sign comes into picture. Okay, so that's why, so from using these two expression you can easily see that the incident wave is occur in the positive z direction, because here minus sign is come into picture, whereas the reflected wave will occur in the negative z direction, means wave is reflected in negative z direction. Okay, and the direction of magnetic field is also opposite, that's why minus sign is come into picture with ax. Okay, so this is the final expression that you will get of the reflected magnetic field. So let us move ahead to the problem number 2. So in the previous problem we have to find out the value of transmitted wave. Okay, so in the previous problem we have find out the value of reflection coefficient, which is equals to 1 by 3. Okay, so the first of all, for finding out the transmitted wave we have to know that what is the transmission coefficient. Okay, so transmission coefficient is defined as 1 plus reflection coefficient. Okay, so reflection coefficient we have already find out in our previous problem, which is equals to 1 by 3. So we have we can put the value of gamma here so as to find the value of tau, that is the transmission coefficient, and the this coefficient will be equal to 4 by 3. Okay, so now we have to find out the transmitted wave of electric field. Okay, so instead, like here in the previous problem, magnetic field is defined to us, incident magnetic field. So by using this incident magnetic field, we will first find out the value of incident wave of electric field, and then by using this incident electric field, we will try to find out the value of transmitted wave. Okay, so like uh, incident electric field, the expression of incident electric field in general is defined as E I naught cos of the same argument that you will see in the previous problem. Okay, so the same argument, that is 10 raised to the power 8t minus beta z. Okay, so the same argument will come here. Okay, this defined that the frequency of the uh, electric field as well as magnetic field will remains the same, that is 10 raised to the power 8 radian per second, whereas the phase constant beta, which we will find out in our previous problem, which will be equals to 1 by 3, will remain the same, and also the direction in which the wave is propagating will remain the same, that is the positive z direction. But the difference is that here the amplitude as well as direction of electric field, means the polarization of electric field will be different than the amplitude and the polarization of magnetic field. Okay, so that two quantities we have to find out. Okay, so like for finding out the direction in which electric field is oriented, what we will do, we will use this expression. So the direction of electric field is equal to direction in which magnetic field is oriented into direction in which wave is propagating. Okay, so in the problem, we can previous problem we can see that the magnetic field is oriented along ax direction, whereas the wave is propagating along the z direction. So the electric field is propagating along minus ay direction. Okay, so basically by using the cross product of ax and az, I am finding out in which direction my electric field is oriented. So it is oriented along minus ay direction. Okay, so the direction now we have find out. So only remaining quantity that we have to find out is the amplitude of electric field. So amplitude of electric field is defined as intrinsic impedance of the media times magnet amplitude of the magnetic field. Okay, so eta 1 we have already find out from our previous problem. So it will be equals to eta naught, that is the intrinsic impedance of the air media. Okay, and h naught, the value of amplitude of the magnetic field is 10. So the amplitude of the electric field will be equals to 10 eta naught. Okay, so you can put the value of eta I naught here in this expression and aei here. Okay, so the final incident electric field, that is that we will obtain in the air media, is defined by this expression. Okay, now the transmitted wave, the ratio of transmitted wave and incident wave is defined by the transmission coefficient tau, which will be equals to 4 by 3, that we have already calculated. Okay, so EIO you have already find out. Okay, so by using this we can find out the amplitude of the transmitted wave in media 2. Okay, so here ETO you can put it directly. Okay, the thing is that the wave will propagate in the same direction. So if suppose this is the region where media 2 is occurs. Okay, and this is my free space, so wave is incident here along the along the z direction. So once it transmitted, so the wave will propagate in the same direction, that is the minus sorry plus z direction, and also the orientation of the transmitted wave will remain the same as the incident wave. Okay, so that's why here a et is same as the a ei, which will be equals to minus ay, and the argument will remain the same, which will be equals to 10 raised to the power 8t minus beta into z. So only beta, that is the phase constant, here will be changed because media is different here. Okay, so beta we have already calculated from our previous problem, which will be equals to 4 by 3. So by putting these values, you can easily find out the value of transmitted wave. Okay, so I hope this problem will be clear to you. So now let us move to the next problem. So the problem states that an EM wave travel in free space with the electric field component ES is equals to 150 e raised to the power j 0.866y plus 0.5 z ax in volt per meter. So using this information, we have to solve problem number 3 and the 4. So first of all, we have to find out the wavelength of the wave in this problem. Okay, so here the expression of electric fields defines that it is written in the phasor format. Okay, so which will be defined in general as E naught e raised to the power j propagation constant times the direction in which wave is propagating and the direction in which wave is oriented, that is electric field is oriented. Okay, so this represents that the wave is defined in phasor format. Okay, so as we know that wavelength is defined as lambda is equals to 2 pi by k. Okay, so lambda is defined as 2 pi by k. So if we will find out the value of propagation constant, then we can easily determine the value of uh, uh, wavelength. Okay, so we here uh, our task is to find out the value of propagation constant. Okay, or say phase constant, because it is traveling in free space, so both are same actually. Okay, so but the problem here is that the wave is not traveling only in one direction, that is along x, along y, along z. It is uh, uh, propagating in the yz plane. Okay, means it has both direction, that is y as well as z. Okay, so we have to first understood that what is the in general expression of this kind of wave solution. Okay, so the general expression of this kind of solution is written as E naught e raised to the power j kx into x plus ky into y plus kz into z. Okay, where kx is the propagation constant along the x direction, ky is the propagation constant along the y direction, and kz is the propagation constant along the z direction. Okay, and ax is the direction in which electric field is oriented, which is already given in the question. Okay, so what we will do, we will compare these two expressions. Okay, so here we can see that the propagation constant along the x direction is 0, that is kx will be 0, whereas the value of ky will be equal to 0.866 and the value of kz will be equal to 0.5. Okay, so net propagation constant is defined as root over kx square plus ky square plus kz square. So kx value is is 0 here, ky is equals to 0.866, kz will be equals to 0.5. So by using this expression, we can determine that the net value of phase constant will be equals to 1. Okay, so once you find out the value of k here, you can determine the value of wavelength, which will be equals to 2 pi by k is equals to 1 here. So the net wavelength will be equals to 6.283 meter. Okay, so now move ahead, and so the next problem states that we have to find out the magnetic field component. Okay, so here electric field is given to us. Okay, so we have to find out magnetic field component by using this information that is already given in the question. Okay, so as we know that magnetic field is defined by this expression, that is 1 over eta times ak, that is the direction in the propagation occur, direction in which propagation is occurring, and we have to take cross product with ak with es. Okay, so here the direction of in which propagation is occur is defined as 0.866 ay plus 0.5 az. Okay, and es is already given to us. Okay, so that I am written here. Now eta, that is the intrinsic impedance of air media, because here free space is given to us. Okay, so that I am directly putting here as 120 pi. Okay, so we have to just take cross product of these two quantities. So once you take the cross product of these two quantity and simplify, you will get this magnetic field is defined as 0.19 ay minus 0.34 az times e raised to the power j 0.866 y plus 0.5 z in ampere per meter. Okay, so I hope this problem will be clear to you. So now move ahead. So here is the next problem, which states that a uniform plane wave is incident at an angle of 45. So here is the incident wave. It is incident at an angle of 45 from the incident, from the normal of this boundary. Okay, so here is the normal and this is the boundary. So from normal it is making an at an angle of 45 degree on a pair of dielectric slab. Okay, so here is the first dielectric slab, here is the another dielectric slab. Okay, which is shown in this figure. So we have to determine the angle of transmission, that is theta t1 and theta t2. Okay, angle of transmission we have to find out. So for solving such kind of problem, what we will use Snell's law of refraction. Okay, which is defined as k1 into sine of theta I is equals to k2 into sine of theta t. Means the propagation uh, constant in media 1 times sine of angle in which it is incident. Okay, so this is the k1 sine of theta I. This will remains equals to k2, that is the propagation constant in media 2 times sine of angle that it is making uh, with the normal. Okay, that is theta t1. Okay, so here k1 is defined as k1 is remains the same because it's a free space. Okay, so what I am doing, I am written here the k2, that is the dielectric constant of media 2 in terms of k1. Okay, so that's why I am directly cut this k1 from here in this expression, and I am directly writing here root times 4.5. Okay, because k is defined as omega root over mu epsilon. Okay, so epsilon here is defined as 4.5 times epsilon naught. Okay, so once you put this in the expression of k, so you will find that this will be equals to root over 4.5 times k1. So k1 will cancel from both sides. So this is the net expression that you will get. Okay, so by solving this expression you will get theta t1 will be equals to 19.47 degrees. Okay, so it means that the angle of transmission that it is making from the normal of the this boundary is 19.47 degree. Okay, so once you know this angle, so this angle will remains the same from the alternate angle. Okay, so here the incident angle at the boundary 2 will remains the same as theta t1, which will be equals to 19.47. Okay, so now by using this we can determine the value of theta t2. So we will use the same expression that we have utilized previously. So here only the propagation constant will be changed, because in media 2 we have already seen that it will be equal to root of 4.5 times K1. Okay, so similarly we can define K3, which will be equals to root of 2.25 times K1. So K1 and K1 will be cancelled from each side, and theta T1, which we have already find out previously, so we will put here, and by using this expression we can determine the value of theta T2, which will be equals to 28.12 degrees. So that's how we can utilize the concept of Snell's law of refraction, so as to find out the transmitted angle, or say let us say transmitted angle is given to us, so we can find out vice versa, that is the incident angle we can easily find out. Okay, so let us move ahead. So here the next problem states that a glass surface is coated with an appropriate dielectric layer to provide a total transmission from air to the glass at a wavelength of 570 nanometer. The glass has the dielectric constant of epsilon r is equal to 2.1. So we have to find out the required dielectric constant of the coating. Okay, so let us suppose a glass is given to us. Okay, so our task is to put a dielectric layer above this glass such that whatever transmission occurs from the air, the whole transmission will occur towards the glass. Okay, means no reflection will be occur, total transmission will be occur at the glass side. Okay, so for that we have to find out the dielectric constant of the uh, dielectric coating. Okay, so this problem we can easily understood by using the transmission line. So here we can consider the glass as one kind of transmission line, air as the another kind of transmission line, whereas the dielectric coating that we will provide in between the glass and the air, it's a third kind of uh, transmission line. Okay, so we know that for air the impedance is defined as 120 pi, which will be equals to 377 ohm, whereas intrinsic impedance for the glass, for which dielectric constant is given to us, which is equals to 2.1, we can easily calculate the dielectric intrinsic impedance for the glass. Okay, which will be equals to eta naught times root over epsilon r. So epsilon r value is given to us, that is 2.1. So we can directly put the value of 2.1 here so as to calculate the intrinsic impedance of the glass media, which will be equal to 260 ohm. Okay, so once you determine the value of eta 1 and eta 3, we can easily determine the value of eta 2, which will be equal to geometric mean of eta 1 and eta 3. Okay, so we can put the value of eta 1 and eta 3 here. Okay, and calculate the value of eta 2, which will be equals to 313 ohm. Okay, so eta 2 value is already known to us. Now by using this we can easily calculate the value of dielectric constant. Okay, so it is defined as 313 is equals to uh, 377 divided by root over epsilon r dash. Okay, so by using this we can calculate the value of epsilon r dash, which will be defined as 377 over 313 square. So once you calculate, you will get the value of epsilon r dash is equal to 1.45. Okay, so that's how we can calculate the dielectric constant of uh, dielectric coating. Okay, so let us move ahead. So our next problem is light is incident from air to glass at a Brewster angle. The incident and transmitted angles are. Okay, so first of all, we have to know that what is a Brewster angle. So Brewster angle is the angle at which the incident angle. Uh, let let me see whether my pen is working or not. So Yeah. So let us suppose, uh, yeah. So Brewster angle is defined as the angle at which uh, the incident angle is forming from the normal to the boundary. Okay, so let us say this is theta I. Okay, so it is the angle which the incident angle is forming from the normal to the interface, such that the total reflection will take place. Okay, means there will be no uh, reflection will not take place, the total transmission will take place. Sorry, actually this will be transmission instead of reflection. So the total wave which is incident here, it will be transmitted to the region 2. There will not be any kind of reflection here. Okay, so this angle is known as the Brewster angle. Okay, so we have to find out the value of incident angle such that the whole transmission will be takes place. Okay, so there will not be any kind of reflection. So for that, as we know that uh, the transmission coefficient is defined as t is equals to 2 eta 2 cos of theta I, that is the incident angle that is forming wave from the normal of the dielectric boundary. Okay, divided by eta 1 into cos of theta t plus eta 2 cos of theta I. Okay, so here eta 2 is the intrinsic impedance of this media. Okay, and eta 1 is the intrinsic impedance of the media 1. Okay, so we have to uh, know that in case of Brewster angle the transmission coefficient should be 1. Okay, means whatever will be the incident, the whole will be transmitted to the medium 2. Okay, so here by using this we can determine uh, this 2 eta 2 cos of theta I will be equals to eta 1 cos of theta t plus eta 2 cos of theta I. Okay, and uh, this we can simplify as eta 2 cos of theta I is equals to eta 1 cos of theta t. Okay, so theta t we can easily replace as eta 1 root over 1 minus sine square theta t. Okay, so as we know from Snell's law of reflection, eta 1 sine of theta theta I is equals to eta 2 cos sine of theta t. Okay, so from here we can determine the value of sine of theta t, which will be equals to eta 1 over eta 2 sine of theta I. So we can put the value of sine of theta t here. Okay, by using Snell's law of reflection, and we will simplify this. Okay, so by using some mathematical manipulation you will find out this as sine of theta I is equals to eta 2 over root over uh, uh, eta 1 square plus eta 2 square. Okay, so the value of eta 2 and eta 1 we have already know. Okay, so eta value of eta 2 is equals to 1.45, and the incident this is given to us. Okay, so yeah, so eta 2 and eta 1 is already given to us. So by putting the value of eta 2 and eta 1 we can determine the value of theta I. Okay, so once you determine the value of theta I, the uh, we can determine the value of uh, transmitted angle from the uh, from this expression, that is the uh, Snell's law of reflection. Okay, so sine of theta t is equals to eta 1 over eta 2 into sine of theta I. Okay, So by using this expression, we can determine the value of transmitted angle. Okay. So the next problem states that the required condition for total internal reflection is, so basically internal reflection is the condition in which the incident wave will not transmitted to the region 2. If suppose this is the region 2, this is the region 1, so whatever wave is incident here, it will not go in the region 2. Okay, so at a particular value of incident angle, let us say it is critical angle, so in this critical angle, the whatever wave is incident, it will uh, travel at the boundary itself. Okay, it will not go in the region 2. Okay, so if suppose uh, we will we want that whatever wave will be incident, it will totally reflected inside the region 1. So in that case, the incident angle, that is theta I, so theta I should be greater than theta c, that is the critical angle, then only total internal reflection will be takes place. So here option C is the correct option. Okay, so option C is the correct option. So incident angle in the denser medium will be greater than the critical angle for the two media. Okay, so let us move to the next problem. So the problem states that in a non-magnetic media, electric field is defined to us, that is 4 sine of omega t minus beta x. So omega value is given to us, that is 2 pi into 10 raised to the power 7 radian per second, and beta is given to us, that is 0.8. Okay, so these values given to us. So based on that, we have to find out the dielectric constant, that is epsilon r, and intrinsic impedance as the first part of this problem. Then in the second part of this problem, we have to find out the time average power carried by the wave, and the third part in the third part we have to find out the total power that is crossing 200 centimeter square area, and which is occurring in the plane of 2x plus y is equals to 5. Okay, so let us first find out the a part of this problem, which is epsilon r. So first of all, in the problem it is given that it is a non-magnetic media. Okay, so non-magnetic media, mu r will be equals to the 1, but epsilon r we cannot say that it will be equals to 1. Okay, so we cannot directly use this formula, that is beta is equals to omega by c, because beta is given to us, omega is given to us, and c we know that c uh, c is defined as 1 over root over mu naught into epsilon naught. Okay, but in this problem epsilon r we have to find out. Okay, because it is not a free space. Okay, it is some media is there, so that's why epsilon r will be there. So beta in this case will be equals to omega by v. Okay, and here omega by v means 1 over root over mu naught epsilon naught into epsilon r. So by using this expression, we can find out the value of beta. Oh, sorry, we can find out the value of epsilon r. So once you find out the value of epsilon r, you will get epsilon r as 14.59. Okay, so once you get the value of epsilon r, so by using this expression, that is eta is equals to root over mu over epsilon, you can find out the value of intrinsic impedance. Okay, so here it will be equals to root over mu naught over epsilon naught into epsilon r. So value of epsilon r we have already calculated, which is equals to 14.59. So we will put the value of mu naught epsilon r here. Okay, so the calculated value of intrinsic impedance will be equal to at 98.7 ohm. Okay, so let us move ahead and find out the B part of this problem, that is the time average power carried by the wave. Okay, so as we know that the time average power that a wave is carried is defined by the pointing vector, which will be equals to E cross H star. Okay, E cross H star. So value of E is given to us. Okay, so value of E is given to us. It is equals to 4 sine of omega t minus beta z. Okay, and H is we define as E by eta. Okay, so means H we define as E over eta. Okay, so I am considering the magnitude here. Okay, so we can put the value of E and H here. So the pointing vector is defined as E naught square over eta sine square omega t minus beta z into ax, means wave is propagating along the x direction. Okay, so once you find out the pointing vector, so the average power flowing is calculated as 1 by t integral 0 to t p dot dt is equals to E naught square by 2 eta into ax. So you can find out the average value of pointing vector, and it will come equals to E naught square over 2 eta. Okay, so E naught is given to us in the problem. Okay, which is equals to 4, and eta we have already calculated in our previous part of this problem. Okay, so once you put the value of E naught and eta. So the calculated value of time average power is equals to 81 milliwatt per meter square along AX. Okay, so now the third part of this problem states that we have to find out the total power that is crossing 200 centimeter square, means this is the area, and the plane is also given to us in which this area is occurring. Okay, which is equals to 2x plus y is equals to 5. Okay, so by using this uh, expression we can find out, we can determine that in which what is the area vector of this cross section. Okay, so for determining the area vector, this uh, plane is given to us. Okay, so area vector is defined as an is equals to 2ax plus ay divided by root over 2 square plus 1 square. So this we can find out. So now once we find out the value of average power, and area is also given to us, which is equals to 100 centimeter square, and area vector is also given to us, so we can directly take a dot product of average power, which is 81 ax milliwatt per meter square, and take it dot product of 100 centimeter square into uh, area vector that we have calculated in this previous part of this problem. Okay, so once you put this value and take a dot product, you will get the total power that is crossing through the area will be equals to 724.5 microwatt. Okay, so this was the last problem. So I hope that this session will be informative to you. Thank you.